Hello class. Today we're going to talk about the centroid of a triangle. So to begin, start with any triangle. And what I'm going to do next is find the midpoint of each side by folding each side onto itself so that the vertices match up and just pinching it. We've done this before. So there's one midpoint. Now we'll repeat by folding the next side onto itself and pinching it. Here's my second midpoint. And finally folding the third side onto itself, folding it in half, and pinching it. Okay, I've located the three midpoints of this triangle. Now I'm going to connect each midpoint to the vertex opposite. All right, so my first question is, what segment in a triangle did I just draw 3 times? My next question is what do you observe about the point of intersection of these 3 medians in the triangle? Okay, hopefully all of you found that the 3 medians of the triangle all intersected in a single point. When 3 or more lines or segments intersect in a single point, the point of intersection is called the point of concurrency. Lines are concurrent when they intersect in one point, but we're talking about more than 2 lines. The point of concurrency of the 3 medians of a triangle is called the centroid. So next, we're going to observe some properties of the centroid. So the first thing I would like you to do is to measure the 2 segments that the centroid divides each median into. All right? The centroid divides each median into 2 segments, and you're going to measure them. Let's use centimeters because that's easier. All right? So it looks like this segment here is, let's call that 3.8. And this segment here is, let's call that 1.9. Now, please measure that for yourself and then repeat the process on the other 2 medians. Measure the long segment and measure the short segment. And then let's discuss what we observe. Okay, so after you've measured, please think of making a clear statement of what is the relationship between the segment of the median between the vertex and the centroid versus the segment of the median between the centroid and the midpoint of the side opposite. All right, so there are 2 segments from the vertex to the centroid and centroid to midpoint. What is the relationship between those 2? All right, so we can state that relationship in 2 ways. This long part is twice the short part. So there's a 2-to-1 ratio between the long segment and the short segment. Another way to state that is that this longer segment between the vertex and the centroid is 2/3 of the whole median. All right, now we're going to take some notes on those things that we have just discussed. All right, Next, I'd like you to turn your attention to the cardstock triangles that I gave out in the beginning of class. We're going to find the centroid of that cardboard triangle by using measuring to find the midpoints. Now, I actually only need 2 of the medians to locate the centroid because I know that all 3 of them intersect in one point. So where the 2 medians intersect is going to be the same location as where the 3 medians intersect. So this side here looks like 21 centimeters. So the midpoint of this side would be at 10.5. This one here appears to be 9.4 centimeters. So the midpoint would be at 9.4 divided by 2, which is 4.7 centimeters. All right, so again, to draw the median, I connect the vertex to the midpoint of the opposite side. And now I'll repeat that. I'll connect the vertex to the midpoint of the opposite side. And where these two intersect is called the centroid. I don't have to do the third median because I know it's going to intersect in the same point. All right, now take a nice flat pencil eraser or something else and check out this little trick here. The centroid turns out to be the balance point for the triangle, where it balances on like the tip of a pencil or something else. All right. So I'm going to ask you if anybody knows what that is called, and then we're going to take some notes on that. The end.